Hello, and welcome back to another GED math video. My name is Jillian. I teach GED classes at Jessamine County and Woodford County Adult Education. And today we are going to have a little introduction into equations. And we're starting with just very simple one-step equations. If you have not yet watched the evaluating expressions video, that might be helpful before you start on this one. So if you haven't, I'll put a link to that one down in the description box. But it's a good foundation one to have before this one. So as we think about equations, I want to kind of make a little illustration before we start, kind of start to have a concept of what we're doing here. So let's imagine these are two baskets of apples, since I can draw in red. And in this basket, we have 1, 2, 3 apples. And in this basket, we have 3, 4, 5, 6, 7 apples. Okay, so this basket has 3 apples. This basket has 7 apples. And I drop another little handful of apples into this basket over here, okay? But I don't know how many I dropped in. It's just like, blah, blah, blah. I dropped a bunch of apples in there. And I tell you, these baskets have an equal number of apples in them, okay? So however many are in this one, the same number are in this one over here, okay? How could we figure out how many apples I dropped into this basket at first so that this one would be equal to this one? Well, we can think probably we all can kind of figure this out without doing any math whatsoever and think, okay, if there are 7 over here and I already have 3 over here, how many more do I need to make 7? Well, I need 4 more. But let's think about how we could figure this out without, let's say we never knew anything about math and we wanted to figure it out. Well, one way is to say, okay, we want to know how many is in here. So let's take out these 3. Let's take out 3 apples from each one and see how many are left. So if we eliminate 3 from this one and we eliminate 3 apples from this side, we can see, okay, we have our little mystery box over here and 4 apples here. And these are both equivalent still because we took the same amount away. So we have 4 apples in this mystery box. A lot of times people will also use like a scale for this to say, okay, to keep things even, we would have to take away the same number on either side. Solving an equation is very similar to this. And what I usually tell students when we first start learning how to solve equations is that typically up to now in math classes, you have been very concerned about what comes after the equal sign. So you have this problem and you're trying to figure out what does it equal. In equations, we're not so much worried about what is on this side of the equal sign. We are worried about maintaining the equivalency, maintaining this perfect balance between what's on this side of the equal sign and what's on this side, keeping them the same. So as we are solving equations, all we're doing is maintaining that balance between what's on the left side of the equal sign and what's on the right side of the equal sign. So let's kind of see what I mean about that. So let's look at this problem here. Let's use our variable as p. The variable can be any letter at all, but we're just going to use p right now. So p plus 32 equals 61. Okay, p plus 32 equals 61. So think about this as a scale again, where this equal sign represents perfect balance. Everything on this side and everything on this side are in perfect equivalent balance. So with an equation, our goal is to figure out what this variable is. That's our goal. To solve an equation, we're finding out what this is equivalent to, okay? So our end goal is to have P equals something, okay? So as we're looking at this, there's something standing in our way from having P all by itself on this side of the equal sign, right? And the thing that's standing in the way is this plus 32. We got to get rid of this plus 32. So when we're working on equations, one way, the only way to get rid of terms on one side of the equation is to use the inverse operation, which is the same as saying the opposite operation. So what's the opposite of addition? Well, subtraction is the opposite of addition. So one way we can get rid of a plus 32 is by subtracting 32, right? So P plus 32 minus 32, it's like you did nothing at all. They cancel each other out. Just like if I gave you $32 and I took it back away from you, you're the same as you were before I ever came into your life, right? So as we're doing these inverse operations, we're kind of canceling this out to make it like it never happened. So we subtract 32 from this side of the equal sign, but now we've ruined our perfect balance. Before, everything on this side was equivalent to what was on this side, but now we've messed with what was on this side. So in order to restore that balance that we used to have, we need to also take 32 away from this side of the equation. Okay, so to keep that balance, we need to do whatever we did on this side also on this side. Okay, so let's kind of work out our problem. So this is how I typically write out equations. I go down like this. And as we get into longer ones, we'll kind of see how that plays out. People do this many different ways. Whatever works for you is fine, as long as you have a way to keep things a little bit organized. So let's look at this side. P plus 32 minus 32. These make 0. So now we have P all by itself, right? P plus 32 minus 32 is just P. All right, and we're going to bring the equal sign down just where it was, equals. And then 61 minus 32 is 29. So in this equation, we've done it. We've gotten our variable all by itself on one side and the number that it's equal to on the other side. P equals 29. 29. And if we went back to this problem, P plus 32 equals 61, we could use our skills from evaluating expressions and say, okay, if P equals 29, I can substitute 29 for P, and this should work out fine. 29 plus 32 equals 61, and it does. That's true. 29 plus 32 equals 61. So we've done this correctly. So as you're solving equations, if you're not sure if you did it right, or just as a good rule of thumb, it's always a good idea to substitute whatever you come out with here with your variable down here so that you can double check yourself, make sure you did it right. Let's think about some other equations. Let's think about subtraction. So let's say we have x minus 14 equals 54. Okay, so here again, our goal is to get x all by itself. What's stopping us from getting x all by itself? This minus 14. Okay, so we're going to use inverse operations here to get rid of this minus 13. We want to get rid of that. So the opposite of minus 14 is plus 14. So now our problem is x minus 14 plus 14. Okay, But what we've done over here has messed up our balance. Again, that perfect balance between what's on the left of the equal sign and what's on the right of the equal sign. So in order to bring that balance back, we got to add 14 over on this side. Okay, so let's work out our problem. X minus 14 plus 14 is just X because these two cancel each other out. Okay, we drop down our equal sign right where it is. And then we look over here and we say 54 plus 14 is 68. So X equals 68. And we can double check ourselves by substituting X with 68 in the problem. 68 minus 14 does indeed equal 54. So we've done this correctly. Okay. Let's think about multiplication and division now. Okay, so we know that addition and subtraction are opposite operations from each other. The next step of this is to think about multiplication and division as inverse operations of each other. So, for example, let's say you have 16D equals, let me work one out real quick so we don't end up with a crazy decimal. Okay, 16D or 16 times D equals 224. Okay, if we have 16 times D equals 224, what is standing in the way of us getting that D variable all by itself? Well, we're multiplying it by 16. So we got to get rid of that. We've got to get rid of this times 16. And the way to do that is to divide by 16. Okay? So 16 times D divided by 16 just gives us D by itself. Because if you multiply a number by 16 and then divide it by 16, you end up with your original number again. You just kind of circle back to the beginning again. All right, but once again, we've messed up our perfect balance on each side of this equal sign. So whatever we did on this side, we also need to do over here. So we've got to divide 224 by 16 as well. And 224 divided by 16 is 14. So D is equivalent to 14. Okay, and we can substitute this and do 16 times 14. Does it equal 224? It does equal 224. So this is a correct solution to this problem, that D equals 14. Okay, let's do a division one. Let's do Z divided by 25 equals, oh, I just did 16, didn't I? One trick pony. We'll say 7. Z divided by 25 is equivalent to 7. So once again, multiplication and division are opposites. So we're going to multiply this side by 25, multiply this side by 25 to get out. Okay, so for this one, we have Z divided by 25 times 25 here. So Z divided by 25 times 25 is just Z. Again, if you have a number and you divide it by 25, and then you go back and multiply it by 25, you end up with your original number. And then on the other side, we have 7 times 25, which is 175. So the solution to this equation is Z equals 175. And we can substitute that in. 175 divided by 25 equals 7, and it should 175 divided by 25 equals 7. So we're in good shape there. So this is how you'll do your inverse operation for division. Now, 90% of the time, if not 100% of the time, when you see division in algebraic equations, you're going to see it with this fraction bar like this. And there are a couple of little hangups that can happen that people get a little confused about. So let's just go over a couple special cases. So let's take the equation 1/2 times p equals 156. I feel like I just used that. Okay, so 1/2 times p equals 156. So here we have a fraction bar, but it's for an actual fraction. So a lot of times students will ask me, well, how do I know if it's a division problem or a multiplication problem when you have a fraction like this? So this problem, we are multiplying 1/2 times p. So in order to get rid of this 1/2, we have to divide by 1/2. Okay? If your variable is part of the fraction, so if it was p over 2, or over anything, then this is a division problem. But if it's a fraction and then the variable is next to the fraction, that's a multiplication problem. Okay, so for this one here, the fraction is next to the variable. So this is a multiplication problem. So we would go ahead and divide each side by 1/2, which would make on this side, we would have p, because when you multiply p by 1/2 and then divide it by 1/2, you end up with just p at the end. And then 156 divided by 1/2 would give us 312. Okay? The other thing that might throw you for a loop is, so far I've made all of our equations with the variable on the left-hand side of the equal sign, but sometimes you'll have your variable on the right-hand side. So maybe you might have 48 equals x over 3. Okay? This you solve in the exact same way. You still want to get x all by itself. It doesn't matter if it's all by itself on this side of the equal sign or this side. They're interchangeable. So to get x by itself on one side of the equal sign, doesn't matter which side, we would multiply by 3 and multiply by 3 over here. X divided by 3 times 3 is just x. 48 times 3 is 144. So this one comes out like this, but it's the same thing. And if you feel better writing it, x equals 144, you can just flip them around. Since they're equivalent, it doesn't matter which side of the equal sign they're on. Okay, so let's do some practicing with this. Let's see. Let's see if I have a good worksheet loaded up. All right. So here we have a bunch of different examples. So we're going to try them out. Okay, get rid of that. All right, so like other videos that I've done for this one, I'm going to go through and work each of these problems out individually. So if anybody has any issues with them, they can go to that part of the video and watch me solve it. But if you want to give these a try, and I encourage you to do that, pause the video here and work these problems out on your own on a piece of paper, and then fast forward to the end and I'll have all the answers up on the screen and you can check yours against mine. Okay, so let's get started. Make sure I've got a little point here. Okay, so this first one is another of those where the variable is on the right side of the equation, but it really does not matter at all. We do the same thing. We want to get v by itself, So we're going to subtract 8 from both sides. So 8 plus v minus 8 is just v. And 26 minus 8 is 18. So 18 equals v. All right, number 2, 3 plus p equals 8. Well, we can subtract 3 from both sides, and we end up with p equals 5. Put that little line just to keep things consistent. All right, next one, 15 plus b equals 23. We're going to subtract out 15 from both sides, and b equals, I'm just gonna use the calculator. I don't want to get anything wrong. All right, b equals 8. Okay. This one, negative 15 plus n equals negative 9. So for this one, even though we have a negative number here, it doesn't matter. We're gonna do the same thing that we did before. We're just gonna consider this negative sign as part of this number. Okay, so we're adding negative 15 here. We're going to subtract negative 15. Okay, and we're going to do that on this side. So we'll do minus, put a parentheses there to keep things straight. So minus negative 15. And we end up with negative 15 plus n minus negative 15 is just n. 9 minus negative 15 is 24. Okay. Oh, no, hang on. It's negative 9 minus negative 15. So negative 9 minus negative 15 is 6. Sorry, I blocked off my own negative sign there. All right, so next one, m plus 4 equals negative 12. We're going to subtract 4 from both sides. We end up with m equals negative 16. Okay. Next, we have x minus 7 equals 13. We're going to add 7 to both sides, and we have x equals 20. All right, m minus 9 equals negative 13. So we're going to add 9 on this side, add 9 on this side, and we end up with m equals negative 4. All right, next one, we have p minus 6 equals negative 5. So we're going to add 6 on both sides, and we end up with p equals 1. Negative 5 plus 6 is 1. All right, next, we've got v minus 15 equals negative 27. So again, we're just going to add 15 on both sides, and we end up with negative 12. Negative 27 plus 15 equals negative 12. And just, I know this is a little late, but on these calculators, if you're doing negative numbers, this button right here will make a number negative. So if you want to make negative 12, you would do negative 1, 2, just like that. And it comes with that negative sign. Okay, so if you are struggling with that, I know there's 2 separate buttons for this. There's the subtraction button and then the negative button. So just make sure you're using those correctly. All right, number 10, n plus 16 equals 9. We're going to subtract 16 from both sides, and we end up with n equals 9 minus 16, negative 7. All right, and last one, we have negative 104 equals 8 times x, or 8x. We're going to divide this side by 8 and divide this side by 8. I'm going to put this over here. So negative 104 divided by 8 is negative 13. Negative 13 equals x. Okay. And over here, 14 times b equals negative 56. We're going to divide, again, each side by 14 so that it's b equals negative 56. And that will give us negative 4. Okay, I will link some more practice down below, especially more practice in multiplication and division. But do practice this, get really comfortable with it, because if you know how to do this, going up to more difficult equations is going to be a breeze for you. So get really good at this. In the next video, we're going to be looking at multi-step equations. Thank you so much for watching.